Hello and welcome to part 4 of Dev Maths and Stats Refresher course, lecture 3. Let's continue with the rest of these examples on partial differentiation. And so I think we're going to skip that one and come to this one. So here the function is e to the x, y is the y cubed minus 1. So this is starting to look a bit more interesting. So the function is e to the x, y cubed minus 1, that's right. So we want to find f of x. Okay, so I'm going to start cutting some corners now. This is clearly a chain rule one, so we're really looking at e to the u, and u is equal to this thing here. So when we differentiate this, we know that this will just remain because e to the u goes to e to the u, so that will always just remain there. But we have to multiply by the derivative of u. So when we're doing the partial derivative with respect to x, we need the derivative of this with respect to x, which is just y cubed. So this is a constant. This disappears. Well, this differentiates to 1, so you have y cubed. That's this partial derivative. This time, we have, again, this will stay here because e to the u, when you differentiate, you get e to the u. Now we multiply by u differentiated, but this time we have to differentiate this with respect to y, because u is the exponent here. So this time, that was the first one I did. Differentiate with respect to x, it's y cubed. So I was multiplying this, multiplied by this, gives you this. But now I'm doing this derivative. So differentiate this, you have 3x y squared. This goes to 0. So this, that gives you this answer. This will give you this answer. So I have to multiply this 3xy squared. Okay. So when you differentiate this kind of expression, that will remain unchanged, and you just multiply by the derivative of this. So this is partial derivative with respect to x of that with respect to y. So we get these two answers. So you see that this is still there, so we just multiply by the respective derivatives of this part. Okay, please feel free to ask in the live sessions if any of that's not clear. Oops, I just got the answer. Let's get the next one. So here's another exponential one. It's e to the 3x divided by 2xy. Okay, so let's get the partial derivative with respect to x first. This is going to be a quotient rule one, because we got some things which are a function of x on top and some things which are a function of x on the bottom. So let's go through it in a reasonably truncated form. Quotient rule means that on the first of all we differentiate this. So okay, So let's just apply what I just told you, that to differentiate this with respect to x, you're going to go, if this is going to remain there, and then we multiply by the derivative of this with respect to x. So differentiate 3x, you just find 3, so you have to multiply by 3. So that's the derivative of this with respect to x. Then that is multiplied by this remaining unchanged, so times 2xy. So this is the first part of the quotient rule. Derivative of this multiplied by this unchanged. So the dot means multiply. Then because it's quotient rule, we put a minus sign and we do this unchanged. Sorry, I've written it very messily. I don't know why it's on an angle either. Never mind. Times this must be differentiated with respect to x, so that this will give you just 2y times 2y. It says this differentiated times this plus this undifferentiated times this differentiated. And then because it's quotient rule, we're going to remember to divide by this squared, so 2xy squared. So if you did want to simplify it, there's some common factors coming out. There's a 2 here as a common factor, but that's going to be divided by, this will be 4, so it'll be a 2 on the bottom. Okay, well, let's just show we'll cancel out in a minute. So, and there's an e to the 3x as well as a common factor. So e to the 3x is a common factor, and then inside the brackets we'd have 3. Oh, that's not big, is it? 6xy minus 2y, all divided by, this is 4x squared y squared. Okay, so that can be simplified slightly. Yeah, so you've got 3x. So this is cancel the 2. 1x will cancel out, and the y will cancel out. This y will cancel out. Oh, no, the x won't cancel out, sorry. That's 2 divided by 2 has gone there. X has not gone, and 1y has gone. Okay, so that's the first partial derivative. And then we go on to partial derivative with respect to y. And similar to the last example I did, this is simpler because these numbers are now just constants. So really just have 1 over y. So it's this constant times y to the power negative 1. So y to the power negative 1, so you have negative 1 multiplying here, minus e to the 3x over 2x. And then y becomes, from negative 1 goes to negative 2. So it's y power negative 2. So that one's much quicker. Yeah, hopefully that's something like that. Let's expanded this in a different way. But hopefully that compares well. Yeah, so you've got the 3 over 2 x squared y. Okay, that's there, and here it's cancelled the 3. Yeah, and that's simple. Okay. So I think maybe 1 or 2 more examples. I don't want to make the videos too long. Now we've done this with 2 variables, it's easy to generalize to more than 2 variables. So here we have an example with three variables, yes. Well, for some reason we're restarting. Okay, because we're redefining these functions. Okay, so here's function f. Let's look at how we'd work out partial derivatives of that. Let's get rid of this. So f, and I'll write down the thing just for once, x, y, z. So we have 3 arguments for this function. Is 4y cubed minus 6x squared y plus 3x z to the power 4. 4y cubed minus 6x squared y plus 3x z to the power 4. That looks good. So now we can find 3 partial derivatives, because there's this one, and then y, and then z. So partial derivative with respect to x, this is just a constant. Here we have minus 12y, and here we have plus 12 z to the power 4. Okay. Oops, apologies, that should be x, y here, because we have x squared here, so we're left with x. So 12xy here is just x, so it disappears. So that's partial derivative with respect to x. Partial derivative with respect to y. This time we can differentiate this. So we have 12s in this, 12y squared. This one, so minus 6x squared. There are no y's here, so that's constant, that vanishes. And finally z's. So z, there are no z's here, this is constant, this is constant. So this is the only one we differentiate, so we have 12, or the only one that gives us anything. 12x z to the power 3. Okay. So there's the 3 partial derivatives. Let's see if this agrees. Seems to be the same. That's good. Okay, and finally the last example before we go on to applications. Let's have a look at this one. And this time I'll just write f for brevity. So f of x, y, z, I should say, is equal to 7 z 5x cubed minus 3x minus 1 to the power 3 times log of 2y plus 5. Just check we've got the right thing here. So 7z 5x cubed minus 3x minus 1 all to the power 3 times log 2y plus 5. That is good. So let's just jot down the partial derivatives. So if y and z are held fixed and we just change x, this is the partial derivative we expect. So this is just a fixed number. This is just a fixed number. So really we're just concentrating on this part here. Now let's just see if we can apply fairly quickly the chain rule. The chain rule says, imagine this is just a u or m. So we're going to have this to the power 2. So write a little bit more detail, z. Then we're going to have this bracket to the power 2. So it's going to be 5x cubed minus 3x minus 1 to the power 2. And then this 3 will come and multiply it, so it'll be 3 times this to the power 2. But we also have to multiply by the derivative of this inside here. So as well as times 3, from here, we also have to multiply by the derivative of this, which is 15x squared minus 3. So that's the chain rule operating on this. 3 multiplies here, and then you also multiply by 15x squared minus 3. And this is still constant, so that still sits there. Log of 2y plus 5. And you can tidy this up a little bit. So this would be equal to, well, let's not write it without. So this would be equal to 21z times that. So you could cross this off, but 21z times all of this. I think the others are slightly easier than that. So when you come to y, this is fixed, so just dealing with this problem here. And again, it's a similar kind of chain rule situation, that you have 7z, that's all fixed, 5x cubed minus 3x minus 1. It's all just constant, multiplying this here. But this part, if you imagine this is log of q, then log of q, when you differentiate it, becomes 1 over q. So you're going to have okay, let's write that. So 2y plus 5 here, that's the 1 over this. But then you have to multiply by the derivative of this, which is, in this case, just 2. So when we simplify this, then this would be, get rid of this, you have 14 here. So it would be 14z times this bracket divided by 2y plus 5. And then the last one, z, I think is the simplest of all. Extremely simple, because all this stuff is just a constant, so that stays there. That's unchanged. Just differentiate this part and you have 7. So that's the easiest of all. We come back to here, hopefully it's done that. Okay, so hopefully you see that checks out. Okay, so if you have any questions about the ones I've done, or if you'd like to see the ones that I haven't done, please just ask. But I hope you found it useful, and next lecture we'll go into applications of partial differentiation. Thanks for watching.